Yo guys, and welcome back to another week of me building a self-tracking app in Svelte 5. And in this week I continued working on the analytics view that we started having a look at in the previous video. And this analytics service is what's supposed to make the app actually useful. What's the point of tracking all this data if we have no way to make sense of it? So this analytics view should provide meaningful insights to the user based on their data. They should be able to see when their sleep is the highest and what affects their sleep and on which weekday they sleep the best and things like that. So we need to have a way to analyze their data, crunch these numbers and make something useful out of it. And that's what I spent a considerable amount of time on for this week. So I started by creating a new analytics service, and this will be the base for all the number crunching in the application. And the first thing that I do for analytics is that I fetch pretty much everything that we have. We fetch all of the forms in the whole system and we fetch all of the journal entries. So we get all the data that the user has practically stored in their system. Of course, we limit this to a time scope, so I start by just fetching the latest 30 days for running analytics on that, but we could potentially fetch all the data from the dawn of time and analyze that as well. This is to make things more efficient. In the previous version of this app, I actually worked a bit more with variables and I fetched these things individually, but I feel like it's actually easier to fetch everything from the database directly and then do all of the number crunching in JavaScript itself, since the indexed DB API isn't that easy to work with. It's not really that possible to make more efficient queries. We pretty much just want to do this in JavaScript where we have a bit more of an idea of what's going on behind the scenes. So what I start by doing is fetching all of the entries and then grouping these based on their forms. So for each form, we get all of the different questions. We want to be able to correlate different questions within the forms themselves. We might want to correlate the sleep duration, but we might also want to correlate the sleep quality. Maybe we have a different metric for sleep quality. Then based on all of these questions, we regard them as either quantitative or categorical. So quantitative if they're actually numerical values that we can do some number crunching on. If it's a categorical value, then it's something like text. We might have a dinner type that says lunch, breakfast, or dinner. Well, that is a categorical value. We can't add lunch and dinner together and get anything meaningful out of it. But something that we can in fact calculate is the frequency. So we can calculate that I perhaps eat more dinners than I eat breakfast. So I can calculate the frequency of the dinner category, how many times it occurs. And after I've set up all of these form questions, I then loop over all of the journal entries and try to find answers to these questions. I loop over the entry answers. I try to find if it's a quantitative, then I try to parse it as a number and then I set it. And this is also grouped based on the timestamp of the entry. So if we have a different day and we have a daily time scope, well, then we're going to have different groups for these. So we'll group them based on the timestamp as well, so that I can see that my sleep duration on this day is 3000 and on the other day it's 2000. So we want to group that based on the timestamp as well. For numerical values, I can just add that value to the previous value. And for the categorical values, I can just increment it by 1 because that means that the frequency should increase by 1. So after all of this fetching, we now have some raw analytics values. These are the answers to all of the form questions that we have in the system. And then we can do things like calculating the basic quantitative values. We can loop over these values and try to find a day when my sleep duration was the highest. Maybe the 3rd of February I slept really long, and maybe on the 2nd of June I slept for 2 hours. So we want to loop over all of these values, try to find the minimum and the maximum value for the quantitative metric. And then we can also calculate the average. So we just sum up all of these values and then we divide it by how many they are, and then we can get an average value. For the categorical analytics, it's even more straightforward. All we need to do is sum up all of the frequencies and try to find the frequency that is the greatest. So we can get the most common category, and we can also get the least common category based on if the frequency is the lowest or if it is the highest. And of course, we can also calculate the weekday analytics. We will create a map here with the weekday number, and then we will map it to a value. So you want to see that for Monday, my average sleep duration is maybe 7 hours, but for Tuesdays, my average sleep duration is only 6 hours. So we can loop over these entries based on the timestamp. Since we group them by timestamp, we can now figure out on which day that I sleep the longest and on which day I sleep the shortest. For the categorical weekday analytics, we do things a bit differently. What we instead calculate is the max frequency, or the greatest frequency, the category with the greatest frequency for each weekdays. So I can say that on Monday, my exercise type is often cardio, but on Tuesdays, I often have a leg day. So I can see that the leg day category has a greater frequency on Tuesday, while the cardio category has a greater frequency on Mondays. And then comes the even more interesting part. Now we want to do some actual correlations. We want to correlate these different data points with each other and see if there is any strong connections between any of these variables. Does my sleep duration increase if I take more steps during the day and things like that? And in order for this to work, I actually filter the data set so that we only include days when entries actually exist for both of the datasets. If I have sleep duration and step count, well, I only want to correlate when I actually have an entry for both of these values. I could, of course, include it emptily by setting it to 0. I could say that if I did not log my sleep duration for a specific day, well, then I should just set it to 0. But that doesn't make any sense for most of these variables. My sleep duration is not 0. I did not sleep for 0 days. I just simply forgot to track my sleep for that day. So for that reason, I only want to correlate these two different data sets when they both have values for the same timestamp. But here I also added the option first include empty and second include empty, so that I can control that I do want to allow empty values. And then I simply set that second value to be 0. I simply assume that we should fill it out with zeros, and then we just map based on all of the first entries. We just fetch all of the first entries, and for the other, if there is no value for that timestamp, well, then we just set it to be 0. And then it's time to finally do the correlations. So I get all of the data in the whole system and I correlate them with each other. This is not efficient by any means. We correlate pretty much in n squared time because we are correlating each question ID with every single other question ID in the system. But that's what we want to do because we want to correlate everything and make sure that we're not missing. Of course, we're not going to get a different result if we correlate the first one and the second one, or if we have a reverse order with the second one and the first one. So if it is the same data sets but just in a different order, then we can of course skip that. We can of course skip it if it is the same key and things like that. Here I also added the concept of a weekday data set. So I want to maybe figure out if my step count is higher on some specific weekday. So then I also generate an array for each of the weekdays where I set it only to be 1 whenever that weekday is. So if I have a timestamp here, I check the timestamp, I check if it equals the weekday. If it is a Monday data set, then I only set it to be 1 if the timestamp is on a Monday. And when we then correlate with weekdays, then we can include these empty values because we do want to check if we have not logged it on that specific day. And after we have done all of this, we run a simple basic Pearson correlation. I have also tried mixing a bit with Spearman and things like that, but I don't have a statistics background, so I don't really know how all of this stuff works behind the scenes, but I've heard that Pearson correlation is what most people do. It's something I did in the previous version of this app as well, and it's worked pretty well for me. So indeed, I'm going to be running with a Pearson correlation here as well. I also added a bunch of tests for these, and all of them seem to be passing this as well. So we just have some basic tests like fetching the basic quantity values, and we can see the max when it occurred, or the min and when it occurred, also the categories and their frequencies. We also have some basic raw values where we can see how that is set up. And we also have a weekday analytics. We can see for the Monday we have 0, but for the whatever this is, maybe Thursday, it's going to be 15. We have a frequency of 2. And after all of this work, I also started to hook it up with my Svelte frontend. I did not have time to actually implement the more detailed views where we can go in on each of these individual trackables and see their metrics, but I did in fact implement these two charts. So now we get the raw values from all of these trackables, and we can see their values and also the timestamp on which the value occurred. And this also highlights the categorical values. So this food here is a categorical measurement. It's a trackable. If we take a look at this, we can see that what we're logging here is actually rice or fish or meat or chicken. These are not numerical values, but we can have a look here and see that the frequency of meat is greater than the frequency of burger. I eat more meat, I log meat more than I log a burger, for example. I also created a debug view for testing if the correlation engine is working, and we can also see that this is working. For example, with the steps or the income, we can correlate the income with the expenses. So I actually have a scenario here where I log income of 10,000, expense of 1,000. Here I log an expense of 10,000 and income of 1,000. So this will actually give me a Pearson correlation of -1. It's the actual inverse correlation. It's the most strong negative correlation, that my income is going to be exactly greater when this is lower. It's not going to be higher when it is higher. We also have now a lags implemented, so you can see that my mood is actually going to be higher after days when I took more steps. So I tried this out by just creating some journal entries. I took 2,000 steps, then I have low energy, low mood. If I take more steps, here I, for example, take 9,000 steps, well then my mood is higher. Here I take, different amounts of steps. You can see 12,000, then my mood is higher, and we can see that that is a strong correlation here. My mood is higher after days when I took more steps. I can also see a correlation within a form itself. You can see that my mood, how are you feeling, is actually correlated with this high energy pleasant. So whenever I log high energy pleasant, my mood numerical value tends to be higher, and this is also true here. If we take a look here, we have a mood of 10, then I log it as high energy pleasant. Here I log it as 3 when I'm feeling not so happy. Here I also log it 5, it's low, here it's low, here it's higher, and here it's a little bit mixed. But we can see that this correlation engine actually seems to be working pretty well according to the values that I have in the database. So that is all that I had time to implement for this week. I did not really have time to implement all of the views or the front end, so to speak, but now we have a solid backend that we can build upon. Now we have the actual data available to us, and we can start rendering it in the front end to provide hopefully meaningful insights to the user. So I hope that you guys enjoyed this video and that you want to follow along for next week as well, where we build out this analytics view for good and actually start rendering some nice charts in the front end. So feel free to check out the project on GitHub if you want to see how the code evolves, and also feel free to join my Discord channel if you want to be part of the community that I'm trying to build. But other than that, I will see you guys next week. Peace out.